was able to find 3 results. So now this code is working fine. These examples of integer and string and characters, these are pretty simple, pretty straightforward. But then the code that we are going to write for our production application, they're going to be a little more complex than this scenario here. So let's go ahead and take an example uh, of one such scenario. I'm going to add an interface, and I'm going to call it I University DB. I'm going to hit the OK button. Let's change this to public, and this DB is supposed to connect to Entity Framework and fetch data from a database. Let's see if we want to return enumerable of student, and let's call it get students like so. We don't have this class, so let's go ahead and provision that. Generate type student in a new class, and student appears here. Notice that this time it is not public. This is not internal, it is public because the calling class itself was public. Because our university DB was public, it assumed the access specifier of uh, the um, the containing class. So if I now add a couple of properties, we're going to keep it pretty simple. I'm going to add only first name and last name property to these two classes, to this class. Now, our university DB, I can provide a default implementation like public class university DB. It is going to inherit from our university DB, and with the refactoring tool, I can implement this interface. Now, this is the place where I'll be adding a database support. And as we saw in the entity framework class, I'm going to create a context object, and I'm going to call it underscore DB context. And inside the constructor, I'm going to initialize this DB context here. So let's go ahead and add that code. We don't have that interface defined yet. We're going to define that next. I'm going to copy it, public interface I university DB context, and this interface is going to be the actual implementation for this pass-through interface. Let's go ahead and provide an implementation for this, and this is the first time. This is the place where I'm going to assign a proper database name to the application. Because this class is SQLDB, this is a good point or good place where we can specify the type of database that we want to connect to. We want the University DB implementation to be independent of the backend database. This interface here is going to give us that flexibility. Now, with just a couple of overrides, I should be able to switch to a NoSQL implementation. Or if I want to switch to, say, a MySQL implementation, all I have to do is create a new class, inherit from the DB context, and write the entity framework code for that particular application inside these classes. For our example, we can assume that this code here is connecting to EF core, SQLDB, and it is fetching a list of students. I'm going to probably hardcode this for now, and because IEnumerable and array are interconvertible, this statement is going to work just fine. Let's go ahead and quickly add a couple of students, and I'm going to call it, and last name is K. I'm going to pass a B, put a comma here, and this should be good for our example, right? Now, to test this University DB, we're going to add a new test case inside our test class, and I was I was surprised to see that there is no unit test case template available inside this project template. So I've looked in this series and I did not find any unit test case implementation even for XUnit or MS test. So we are simply going to copy uh, this implementation and add a new class to our solution. We can call it university db tests, or I can, just for consistency in name, I'm going to call it should, and we're going to paste the using statement we copied from the stringdb app. Let's go ahead and have the class name and file name in sync. So this becomes should as well. Let's change this to public, and if we start adding fact to this, they're going to become the XUnit test cases. Now another public void method, and we're going to say that count number of students. To create this, once again, we are going to go in the arrange, act, and assert mode. In the arrange part, we are going to define the initial sequence. Now, we know from this implementation that we have two students. So we know that the expected result is 2. We'll have to create a system under test object, which is going to represent the university DB class. So new university DB, and this university DB is going to require a DB context object. So we're going to have to create that. Let's go ahead and call that object context, and I'm going to say underscore context is assigned to new university DB context. Let me look up the name. The name is SQL DB. Right. SQL DB is going to connect to SQL database using Entity Framework. We're going to use this context object and create the university object. In fact, I can take this moment and refactor names a little. I'm going to call it I University. Right? Just to avoid confusion in the names, I'm going to call it University, and in the context, I'm going to leave the DB implementation. Right? So let's go ahead and rename the test case file itself. So with this added, now we know that for the functionality of the university, we're going to require a DB object, and that DB object is going to get us the number of students. Now for the actual count of student, I'm going to say actual result assigned to sut dot get students xo, and then once again in the assert statement, we're going to compare for equality of expected result and the actual result. Like so, the expected result is an integer and get students is returning a series of students. So we might have to call the count function here like so, and for this we'll require system.linkUreference. So let's go ahead and add that using statement, and now we are comparing two integers and they should match. The test case here right now is failing, so let's go ahead and see why it's doing that. In the live unit test, if I go to university cases, they're saying that system.not implemented exception, the method or operation is not implemented, and the method name is get students. Let's go ahead and hit F12, and this method is not yet implemented. So let's go ahead and add the implementation. I'm going to say return underscore db context dot get students. Right? And now the test cases should start to pass. Right. There is only one problem with this test case. This is not a unit test case. Well, not according to many, because we are not testing the university DB code. We're not testing this little function here. We are testing the database from which it is going to fetch the data as well. Now, if something goes wrong at the network side, for example, right, this code here is going to crash, right? And our test case will have to accommodate for those mistakes as well. And because we are crossing the boundary of this particular class and we are going all the way up to database and DB connection and network, this is no more a unit test, this is an integration test. It is also testing the connectivity between our application, our server-side code, and the database. And because we don't want that, we are going to avoid using this context class here. We'll have to figure out a way of not jumping across the network boundary, and we'll be going to figure out a way of providing this context in line alongside the test case. And the trick for doing that is you create a Moq class. So we're going to call a Moq.db, and this time we're going to inherit from the iUniversity DB interface. Let me go ahead and look up the name once again. And we want to inherit from the iUniversity context because using this interface, we are doing the actual DB connection. So let's come back to this interface, the test case, and we are going to implement the iUniversity context database. Now, we are going to use a hard-coded collection of student here. I'm going to call it underscore, because it is public, I'm going to call it student. And when somebody comes and says, give me a list of students, we are going to return this hard-coded collection. So let's go ahead and do that. Return students. Let me change this to plural, and we can go ahead and do an inline initialization of this. And once again, because it is enumerable, it's perfectly alright to assign an array object to it. So this is a new student array, and here I can define the student. So the first name, student, first name equal to, this time I'm going to use and because the definition is not aligning, invalid anonymous member. Just a new array of student, and with this test data added, now we can use this student collection inside this particular context. Instead of the SQL DB, we are going to create a new context and we're going to call it MoqDB. Now, because MoqDB has the same implementation hierarchy as SQL DB, we can pass the context object to university, and when the call to get student is made, the code is going to come and return this hard-coded data from our test case. Now, we might have to change this to mockdb.students.count, and that's how we're going to get the result for students from our case. And with this change made, notice that all the test cases, they started passing, right? The expected result was 3, and then let's go ahead and put a breakpoint inside this, and there's a way we can debug our test cases. I can right click inside the test case and choose option debug test. And because of this breakpoint, we are already inside get students. If I hit F11 at this point, it is going to go to the mock implementation, the mockdb, inside our test case, and it is going to fetch the student from this hard-coded collection. We are not going across network to fetch data from the actual database, and that's why we are back to having a unit test. Right? The count here is going to return 3, and it's going to match with the expected result, and there we have it. The expected result is 3, the actual result is coming from a Moq database, and we are doing the comparison. The reason it makes sense is because some fancy some developer under some requirement might come and write a code like this, that the student first name, it should begin with, start with a capital A. In case some developer puts this requirement, the test case here is going to start failing, right? That is because now the actual value is 1, because there is only one student whose name starts with A, but then the expected result was 3. What we are essentially doing by adding this test case is we are ensuring that there is no additional business logic, such as the square clause, that is getting injected or added inside this particular implementation. Right? It is because of these implementation that we add to our solution, as it is evolving, as the new requirements are flowing in, that we end up breaking the old requirement, and it is called regression. When we have test cases, we can avoid regression, and it is going to prevent our application from breaking the functionalities that were working fine before the actual change started. Now, creating mock like this is called pure mocking, but this is not always very effective. You don't want to have a lot of classes added, just because you want to simulate the data uh, that you can generate and use for your testing. There are better ways of doing this thing, and that option is available to us through multiple frameworks. So Moq is one such framework. There are other frameworks available, like this Moq, mm, like WireMock. It has a decent download count of 2.4 millions. Microsoft has another implementation. It is called Microsoft Fake, and it goes to microsoft.qualitytools.testing.fakes, and it's going to give you an option of shims and stubs, I guess. So there are multiple implementations that are available from different providers. I generally lead onto Moq. This has a pretty decent count of almost 200 million downloads. So let's go ahead, and I've already added it to our solution, and it's going to add this Moq package to our solution. I'm going to close out of this and going to use that. Now, the trick to use that mocking context is you create an object of mock. I'm once again going to call it context. New, if you are mocking the IDB context interface that we use here, we are going to copy the name of the interface, and instead of mockdb, we're just going to use mock and create this object. Now, this function is available in the Moq library, and with the using statement added, this mock is created. Now, the context itself is failing. I'm not sure how the test cases are passing, but to get the object to working, we'll have to pass the context object. The type of context itself is mock generic type I university context, and to access the mocked object of the university context, like one of these classes, we're going to have to use the object property on this context object. Right? Now this test case is failing, and let's go ahead and examine the implementation. And it's saying that the expected was 3, but then the actual what we received is 0. To link this data to this context object, we're going to have to call two functions. The first function is setup. Inside this function, we are going to say that the iUniversity context has a getStudent method. Anybody that issues a call to this getStudents, we want to tab that, we want to intercept that call, and we want to return our own value. to set up that interception line, we're going to call the setup function, and that setup function is going to take a lambda. Now, in this lambda, if I hover over the type of X, it's going to take our university context, and our university context gives me get students implementation. Right? Now, the initial wiring is done, and we want to return the Moq data that we have created. We can continue using this students object from Moq.db. So I'm going to come here and set this to Moq.db dot students, and it's a verb. It returns these students, and with this change added, now we have intercepted the context object, this object, the get student implementation, and when this function is called, it is actually returning this particular object here. We can definitely copy this statement, make it part of our arrange section, and instead of using mockdb, we can use mock of students, and we can also set the expected result or expected result to students dot count, right, like so. And now we are not referring to any outside class. This entire implementation is replaced by these three statements here, where we created the data, we created the mock object from the mock implementation, and then we have set up the get student function to return this hard-coded result from our test case. And once again, if we go back to the university implementation and add that where clause, our test case will start to fail, saying that out of those three expected results, we only got one because somebody has modified the production functionality and is filtering something out. So this is a breaking change. We're going to restore it back to this section. All right. So that is mocking for you. Thank you so much.